English, because the main audience will be listening to us in this language. So thank you for the introduction. So I must say before I start with the contents of my presentation that this is true. We are not many women in computer science, in cybersecurity, but we are quite a lot, and especially in Spain. It's not such a small number. So with this scroll, so let's start. I'm sure you have been seeing all during the day. All the presentations about cybersecurity, hacking, source malicious code, or whatever. And I'm going to talk to you about a concept very related to cybersecurity, which is inside cybersecurity as well. But we could say it's like a top-level concept that involves most of the security in a system, which is trust, and how we can build trust. So, what we are going to see, I'm telling you that most of the work is done in the context of a European training network on cybersecurity. Then I will tell you why we need trust, how we can build trust into the software development life cycle of services. And finally, the conclusions. So, I think, haven't seen all of them, but I would say most of the presentations have been from the industry side, so they are all telling you that what they want, how they do their things, what is interesting for them. But cybersecurity is also done at the academic level, so it is very good, and it is the practical side of cybersecurity, but you need the academic level, at least to start with some career. So you have to have your degree. It is important to have some cybersecurity background. And in some cases, it's good to have a PhD. So, and this will give you some specific training on some specific topic. So the project next is about fostering cybersecurity research in 3 different blocks. So we talk about risk management, information exchange, that is where what my talk will fall today, and cybersecurity operations systems and management. So what we do is we train some early stage researchers to attain a PhD, and as I said, industry is very important, so we don't only consider the academic aspect, but we try that the training is also done at the industry level. So that's the introduction of what is important in cybersecurity at the academic level. Let's say, why do we need trust? So trust is a concept that you use in your everyday life. Suppose this example this case that there is someone who is jumping back, he is sure, let's see, they were, sorry, they are before, he's sure that someone is going to pick him up. So he trusts, and he makes a statement on trust on his mind, saying, well, I trust, these people is going to hold me. But what happens if we don't know what is on the other side? This other guy has to jump, and the other one is telling him, just jump, I will guide you. But he doesn't know what is on the ground where he's going to fall. So in this case, he places a lot of trust in this other guy. And that's what you really do when you use your social networks. We all use, or most of us use WhatsApp, Twitter, Snapchat, whatever. And we all, by default, trust on the others that we interact with. But are we sure who we are talking to? We never know who is on the other side. So to make a parallelism with real life, we need to have another extra services on the top of cybersecurity to protect ourselves for interactions with on the other side, for who is on the other side in any system. So as following the social life or the normal everyday life, we'll say that trust is personal, unique, and temporal because it depends on time. Sometimes you can trust someone, and in the next moment, this person is not trusted any longer. So it's a unique and temporal expectation that the trustor places on a trustee regarding some interaction that has to happen between them. So for doing this at any system, we need what we call a trust model that establishes a relationship in between a trustor and a trustee. And the sources of this model, how you can calculate or compute these trust values, could be with some claims that are done about the trustee, like how it has behaved in the past, how you feel is going to behave, some kind of predictability, or security itself. With all this information, we kind of put them together and come up with a value of trust or reputation. So what we do is, most of the times, if you want to have a trust model, what we do is we have them in a patch-based solution. This means that you have an application, and then you say, well, it would be very interesting for these applications to have a trust model, a trust or a reputation model. For instance, they are not available in most cases. For instance, a very popular case of a reputation model is eBay's or Amazon range of interactions among the users. So, but this is built in the ad hoc model. But the ideal thing that would be the other way around, because in this kind of scenario, if you have the application and then once the application is running, you are trying to insert the trust or reputation model, it will probably not work. So it is better if we insert the trust and reputation model since the beginning of the design of the application. But then whoever is going to develop this service, this trust service, has a problem that he doesn't know how to do it. So there are many interactions and many relationships, but the person who is gathering the requirements for this application, the requirements engineering, doesn't have a guide of how to do it. So we do research, as I'm telling you, this is at the academic level. We haven't done any industrial testing, so everything is academic, but it really works. We want to have our research in between security and engineering and trust management, and doing a new research field that we call trust engineering. So the motivation is that we elicit the requirements of our trust or reputation framework, and we develop a component-based architecture that allows developers to build trust and reputation since the beginning of the design of any service. So for doing that, we had to follow what the security engineers do, is to follow the software development life cycle. This is composed of first planning and visualization. What is your problem? What is the context of your problem? What you want to solve? Yeah, I'm not sure whether you can see. Then it's a security analysis where you have all the requirements of your system. Then there is the phase of design, implementation phase, and then you had to test that everything runs at runtime, meaning that if changes occur in the system, your framework for trust should be able to adapt itself to these changes. And then in the software development lifecycle, there are also two extra phases, which are the controlling the risk management and the assurance of the systems, but these are phases that we are not considering, at least at the moment. So, just as a reminder, we want to integrate trust into the software development life cycle. This will help us to make early decisions about how trust has to be integrated without any surprise at the end of the design of the systems, that they are specific to the system and allows us for some runtime reconfiguration decisions. And this is very useful for developers. So I had to remark that this system is designed for developers. And what we are doing is to provide them with methodologies and tools on how to do this task of trust. So let's start from the beginning of the time is not running. Ah, vale, perfect. Well, so in the planning of this, first of all, we had to analyze what trust is. So then this will give us all the ideas of what is involved in trust. Usually in terms of a trustor and a trustee, some person who trusts and someone who is trusted. Then for an example of how we can do the planning is how to use the best cloud provider. For the design, there are several techniques. I'm going to run on them, but they are based on threat analysis or how to elicit trust requirements. For the design, we can use UML profiles. I'm not sure whether you are familiar, but this is a very well-known language for the design of services. Then the development for our framework, and how we do the runtime verification. So let's go quickly. So let's imagine that we have some cloud providers, and we want to choose which is the best one. So this will be the first phase will be how to elicit the knowledge that we want to achieve. Then there are some trust factors. We define some trust thresholds. So it says, well, below this threshold, we consider this cloud provider is not trusted or is not good enough for us. below, above a certain threshold is good enough for us. Then we had to perform some kind of calculations, and considering some threats that occur, we do this analysis with comparing with some threats are given in clouds. We can have some information. So how the knowledge that we have at the beginning is the information that the cloud providers can give us. And if this information comes from the SLAs, the service level agreements, and all these things that you always, when you contract a cloud provider or a telecom provider, you always say, just sign, or when you just download a WhatsApp or whatever application, you say, yes, as I accept. So all this information is given in these SLAs. How easy is to use the information that these providers give to you. And also what the information others give about these providers. So having all this information that is sometimes available from cloud providers wasn't easy to get, but we kind of achieved it. We have developed, we have grouped all this information in different trust, what we call trust intervals, and it depends if the results from these providers fall in or out these intervals, the providers are not trusted. And we have compared this with some e-health records. I'm going to be quick. And I think it's not easy to read, but the results, we have compared results from providers like Google, Microsoft, Apple, and Amazon, and the threats that we are considering are the famous, the CSIA, the Cloud Security Alliance threats, which are data leakage, insecure APIs. I mean, there is a list of 9 threats given by them. Actually, I think there are now 12. But we haven't analyzed the latest version. So compared to this, we say that the ones that go above the threshold are the blue lines, are more trustable. So if you compare this, it might seem surprising, but in some cases, it seems that Microsoft cloud providers have more threats about the threshold that we are considering. So some other times you have some trust that it's done in between some two entities, but you want to calculate this final trust. So if that's what we call some transitivity. So in this case, we need a kind of a transformation function that allows us to calculate trust in between Alice and Bob, and it is important that we consider a threat model that gives us the threat level that is associated with the interactions that they perform in between them. So as a way of gathering the requirements, we can consider a relationship in between trust levels and sensitivity levels. So if this is a lot of common sense. So if the trust level is very bad, and the sensitivity level of the information that you want to exchange, for instance, if it's a medical record that is very sensitive for the patient, then the risk will be extreme. if is in the contrary, if the trust level is giving us very good, and the sensitivity level is very low, then the threat is very low as well, because it really doesn't matter if it is an exchange. So, and an important thing when we exchange this kind of information is the privacy levels. So imagine that you are exchanging information with someone in order to establish some trust in between the two entities. And at some point you are exchanging a lot of information, and sometimes this information can be very private. So for instance, if you are giving, you are just one person, but at some points you are someone from, I'm myself, but if I want to give more information, I can be Carmen from Malaga, but I can be Carmen from Malaga living in such and such building in that street with the phone number. So at some points you are giving a lot of information. So this is a kind of information that you also have to consider when you do these trust requirements. I'm going to this because we are going to be very quick. So, so for the design, so this was the previous phase. So we have passed to the design phase. So we had to consider how the devices are seeing a kind of what is the reputation manager or the reputation server that we are going to use, and how this is done to make the final decision into the backend server. The way you use is imagine that you have a list of patients and they have a list of physicians, and they had to choose the most trusted one according to the requirements. So if this list of physicians is ordered using this design that we introduced in the previous slide, these physicians are ordered in order to the reputation values, then the decision made by the patient is more informed. So, if we follow the life cycle, we now come, sorry, I'm being a bit quick, but we get to the implementation phase. So we have already, the developer has already gathered all the requirements. There is a design done for the application. And now they had to do through the framework the implementation. So the implementation has to take into account, as I said, all the previous requirements that we have gathered and pass then into the main components of any trust model, which are the entities. I think you cannot see it well, but it's the entities, the relationships that have been established, the kind of model of operation that you are going to use for instance, doing calculating the reputation, the kind of variables, etc. So, and I know that this is not readable, but don't need to read what is inside. So implementation framework has different layers. In first layer, we decide what type of model we are going to use, then how this, the relationships in between the entities are done, what are the interfaces, variables that we use, and then at the end, the final values of the interactions. So that will be a general architecture of how the framework is used. So there will be a trust data store, how the application is the engine dispatcher, which is where the formulae that calculates the reputation is, and all this framework goes into the developer who adapts the system according to the needs of the requirements of the application and gets a final decision what the final client see through the API designed for the client. So a very naive example that we show here. So this is the instantiation of the framework that I showed you before. Let's go a bit quickly. So, and let's go to the last phase of the life cycle, which is runtime reconfiguration. So for doing that, we had used well-known, I'm not so sure it's well-known, but it's known by the research community, models as runtime middleware that is used for designing system at real time using a self-adaptive system. So what we did with Discovery was to insert our trans framework inside this one that allows us to change. So for example, let's imagine that we have two consoles that exchange messages, and we set up a blacklist of bad words that are not allowed in our chat. So in order to do that, we set up our trust values, and the system recognizes the bad words in real time, and if someone in the chat produces these bad words, then the message is rejected. So this is the code that we use for, you see, this code is how these consoles are implemented, but we are too tired, and you are at the last talk, so let's keep it. So, with this, we have completed the life cycle of the design of services, including trust into the services. And I'm not including the examples here, but we are using for Internet of Things scenarios, where we are designing, then taking into account trust since the very beginning of their design. And we believe it can be used for any kind of scenario. So if you want to know more about what we do at the research level, this is our webpage of the NICS lab at the University of Malaga, and we are offering 4 positions if you are interested in working with us. Thank you.